morning to all. I am Mohan, Department of Mathematics. Today we are going to discuss about the introduction to the complex integration. See, the explore the powerful techniques of the complex integration. That the complex integration will be a powerful tool for the mathematics. That is the true. In this complex integration, basically it will be a that it will be a very wonderful topic. Basically, see, it is a concept of residues. In this complex integration, it will be useful for um, the various real life problems. That concept of residues we are discussing with measure of the strength of a function's singularities at a specific point. It will be calculated by evaluating the Lorentz series expansion around the singularities. And the residues play a crucial role in complex integration of Cauchy's residue theorem. See, the concept of the residue theorem, it will be the singular point that integral over f of x equal to 0. That is that the concept of the residues, it will be a strength of a function in singularities. That will be a calculated in Lorentz and the Taylor's series. Then the Cauchy's residue theorem defining residues. See, the residue are special complex numbers associated with the poles of a function. And then Cauchy's theorem states the integral of a function around a closed curve equals the sum of residues with the curve. Then another one is powerful applications allows for efficient evaluation of complex integrals that would be difficult using other methods. See, the defining residues, the residues are special complex numbers associated with the poles of a function. See, the residue with dealing with the poles, that the very important thing, it is in the Cauchy's residue theorem. See, the residues with using the Cauchy's theorem that state the integral of a function around the closed curves. So it is deals with only the closed curve equals the sum of the residues within the curve. So the powerful applications that allows for a efficient evaluation of complex integral that would be difficult using other methods. So then the Cauchy's residue theorem. See here we see that the Cauchy's residue theorem. If we calculate the residue function, a pole, we need to find the coefficient of terms with the higher order pole. Then residues can be computed by taking the derivatives of a function and evaluating it at the pole. See here, the residues can be computed by taking the derivatives of the function and the evaluating at the pole. The powerful technique like the Cauchy's residue theorem allows us to efficiently evaluate complex integration using residues. In these residues, calculating residues, it will be a pole with the deals with the pole of higher order, and then the derives of the function evaluating at a pole, and then the Cauchy's residue theorem that efficiently evaluate complex integrals with residues using residues. Then in this Cauchy's residue theorem will be a calculating. It's very useful and interesting tools they are used. So the every integral f of x equal to 0, then it will be a the value of f of x, it will be 0. Then if the value it will be there exist, then f of z is 2 pi I into f of a. Not only that, f of a, it is deals with the differentiation of f of a and f dash of a and f double dash of a and so on. So that will be a point of calculating the residues. Thank you.